Bismillahirrahmanirrahim. Nahmaduhu wa nusalli ala Muhammad Rasulillahi Kareem. This problem is related to integral transformation. Calculate the Laplace transform of the function ft is equal to sine of 3t using the definition of the Laplace transform. First of all, I give the definition of Laplace transform. Laplace of function ft is defined as limit from 0 to infinity e to the power minus pt into this function is multiplied here ft dt. But here value of ft function of t is sine of 3t. So I put this value here. The Laplace of sine 3t. I put the value of ft both sides in definition of Laplace transform 0 to infinity e to the power minus pt into sine of 3t dt. And now we apply formula of integration by parts. The integration of multiplication of two function. First function as it, integration of second function minus differentiation of first function, integration of second function, and integrate these two values with respect to variable. This is formula. I use this formula, but here differences integration is with respect to t with limit 0 to infinity. So the Laplace of sine 3t is equal to first function. I consider sine 3t is first function and e to the power minus it is second function. So first write first function as it, integration of second function which is e to the power minus pt dt, and apply this limit 0 to infinity on this first term, and after it minus, apply minus, and integrate from 0 to infinity, and differentiation of first function, differentiate first function sine 3t is first function, and integrate second function e to the power minus pt is second function here, and multiplication of these two function we must integrate with respect to t from 0 to infinity. Sine 3t, integrate e to the power minus pt, we get e to the power minus pt, but coefficient of variable t here is minus p, so we must divide minus p and apply. We will apply the upper limit and lower limit. Minus integration 0 to infinity, first differentiate sine which is equal to cos, but here it is not t, so differentiate 3t. We know that differentiation of 3t is equal to, differentiation of 3t is equal to 3 is constant, so only we have to differentiate t. Differentiation of t with respect to t is 1, so differentiation of 3t is 3, so I write 3 here. Differentiation of sine is cos, but differentiation of 3t is 3. I apply here chain rule, and after it integrate e to the power minus pt with respect to t, which is equal to e to the power minus pt, and we know that integration of x is with respect to x e to the power x. What if here coefficient is other than 1, like as e to the power ax. Integration of the e की power x is e की power ax upon divide with a, which is coefficient of x. So e to the power x is equal to e की power x upon x. I apply this formula here and here. So we divide coefficient of t which is equal to minus p, and we get integration of this function, and now integrate whole value with respect to t from 0 to infinity. Apply upper limit. We know that e to the power if we put t is infinity here, we get e to the power p into infinity, which becomes p is equal to minus p e to the power minus infinity. E to the power minus infinity is 0. We know that e to the power minus infinity is 0 because e is greater than 1. So upper limit is 0 minus, now we put e for lower limit we put t is equal to 0. So I show here by putting t lower limit, upper limit minus lower limit. Upper limit we get by putting the value of t in infinity. So I put the direct value here, but I show on putting the lower limit by putting t is equal to 0, e to the power minus p into 0 upon minus p. I give detail here for lower limit. Minus, here 3 upon minus p is constant, so we take out 3 upon minus p from sign of integration 0 to infinity. This becomes e to the power, this becomes cos 3t and e to the power minus pt dt. Again we apply here this formula for differentiation for integration of two multiplication of two function. I consider cos 3t is first function and this value is second function, and apply same formula. Again we get value of 3 into 0 is 0, and so sin 0 is 0 becomes 0. 0 multiplied by this value becomes 0, so 0 minus, it becomes 0 minus 0. This minus sign make this minus positive, so it becomes 3 upon p. Now apply here this formula again. So write first function as it, which is cos 3t, and integrate second function. You can put that direct value and apply limit also, because after it second term will start which is minus 0 to infinity. Differentiate first function, which is cos 3t, and integrate second function, which is e to the power minus pt dt, and multiplication of these integrate with respect to t, again with respect to 0 to infinity. This is 0, so I not write this value and write this value, equation number 1. I will use it. Left hand side is Laplace of sin 3t, but right hand side is 3 upon p, and now integrate this value. You have already done it. So integration of e to the power minus pt is e to the power minus pt divided by minus p, and apply limit which is 0 to infinity. Write limit, upper limit minus lower limit. I will apply limit after next this step. 0 to infinity, and differentiation of cos is equal to minus sine. What we have to differentiate 3t again, which is equal to which become 3, and integrate e to the power minus pt, which is minus pt upon minus p, and integrate this value with respect to t, and close square bracket, which begin with this here 3 upon p